Today we're going to be looking at writing and graphing equations of lines. So to begin, we are going to skip over the warm-up today. You're welcome to try that on your own, but for sake of time with the video, I'm going to go ahead and jump into the new content. So basically we have three different equations of a line that we could possibly have. One of which is point slope form, which is this guy right here. One of which is called standard form, which is here. And our last one is the one we're typically most familiar with, which is slope-intercept form of a line. So these are the three different equations we can use to write the equation of a line. The one thing you want to keep in mind when we're in standard form, we want to have a non-negative a value, and we want to make sure that we have no fractions or decimals. So in other words, we want to make sure we have whole numbers. So that's kind of two of our rules for standard form. Otherwise, the other formats can have any components that they need. So we're going to begin talking about slope-intercept form. Like I said, that's the one we're often most comfortable with, where that m value is your slope, meaning your rise over your run, and your b value is your y-intercept. So slope-intercept form tells us those two pieces. So if our y-intercept is 5, we're going to come from the origin up 5 to create that y-intercept. And if our slope is negative 1/3, that means we're not going to rise 1, we're actually going to sink 1. So we're going to go down 1 and right 3. Now to graph a line, you only need 2 points, but because we've got a little bit more space here, we're also going to create a couple of other points. So back from that y-intercept, I could also go up 1 and left 3. And I've got now 3 points to create that graph. Again, you technically only need 2 points to graph a line, but this just helps us draw a little bit straighter. So point slope form tells us exactly what it says it will. It tells us a point and the slope. So we've got that m value here, that slope. We also have a particular x value and a particular y value. So that is the point that we are referring to. What I would like for you to notice here, though, is it does say minus the x and minus the y. So that means we are actually changing the sign of that when we plug into the formula, which means that when I bring out this x value, I need to change the sign again to undo what they've already done. So the opposite of negative 3 is positive 3. The opposite of positive 2 is negative 2. So again, the reason we're doing that is because in the standard format it has a minus, which changes our sign. So our point is at 3, negative 2, so we're going to come to that point on the graph, 3, negative 2. And then we've got a slope of 4, so we're going to go up 1, 2, 3, 4, and right 1, because any number can be written as a fraction over 1. So rise 4, run 1, or sink 4, and go back 1. So we've got a graph that looks something like that. And there's going to be a question on your homework where if you try to transform that back into slope, intercept, and graph it, it's not going to fit on your graph. So really push yourself to identify what is that particular point and then apply the slope. Now standard form seems kind of strange to people sometimes. Why would we ever want our equation to look like that? But standard form is good to help us identify our x-intercept very quickly and our y-intercept very quickly. So remember, for your x-intercept, that's where you're crossing the x-axis. So at every single point on the x-axis, your y value is 0. So what I'm going to do is I'm going to take that 5x plus 3y equals 15, and I'm going to force the y to be 0. When I do that, I'm going to have 3 times 0, which is basically going to make that disappear. So if I plug in a y value of 0, and I'm going to show my work here a little bit more carefully. So 3 times 0. I'm going to end up with 5x equals 15, which means that x is 3. So my x-intercept is at 3, 0, meaning when the y value is 0, the x value is 3. So I can plot that on my graph. I'm also going to use that equation to find my y-intercept. So 5x plus 3y equals 15. This time I'm going to force the x value to be 0. So 3y equals 15 tells me that y is 5. So when x is 0, y is 5. And I can plot that on my graph. Now again, remember to plot a graph or to graph a line, you only need 2 points. So we've got our 2 points, and we're good to go. So standard form is good to help you identify very quickly what are your intercepts. So this says write the equation of the line in point-slope form, standard form, and slope-intercept form. Now typically people are most comfortable with slope-intercept, so that's where we're going to start. That's that y equals mx plus b format. So looking at this, my b value is 4, since that's a y-intercept of 4. And I'm going to look from one dot to the other to make sure I get an accurate slope. We're going down 1, 2, 3, 4, 5, 6, and right 1, 2, 3. So my slope, remember, is my rise over run. We also see that as y2 minus y1 over x2 minus x1. So if I look at that, we went down 6, so negative 6 for our rise and right 3, which means my slope is negative 2. So I know my slope is negative 2. I know my b value is 4. So my formula is going to look like y equals negative 2x plus 4. And I've given this equation now in slope-intercept form. To put that into standard form, the only thing I need to do is move that 2x to the other side by adding it to both sides. So then I end up with 2x plus y equals 4. Now remember, for standard form we have 2 rules. No fractions or decimals, and a non-negative a value. And in this case, we already have that. Last but not least, it says that it needs point slope form. Excuse me. So with point slope form, that's your y minus y1 equals m times x minus x1. So we already know what the slope is. We found that over here. And now I just want to pick one of the 2 points they identified, either 0, 4 or 3, negative 2. It doesn't matter which one you pick. I'm going to pick the more difficult of the 2 since it's got 2 numbers here. So y minus negative 2 equals negative 2 times x minus 3. Now technically this is in point slope form. However, that minus and negative, I need to go ahead and change that to a plus. And then as far as point slope is concerned, I'm done. I've created an equation using a point and a slope. So those are the 3 different versions of this line. It says, if this equation models the total cost of joining a climbing gym, what would likely be the meaning of the slope and the y-intercept? So if we think about that, most gyms, when we join, they have a fee. To join that gym, you're going to have to pay something. So this is kind of your initial cost. Maybe you had to buy gear, maybe you had to pay to join the gym, whatever that is, that's your initial cost. And this times x here, that's what we're multiplying by our variable. So more than likely, this is your cost per month or week or whatever that is. But that's your cost over time. How much are you paying continually to be a part of that particular gym? So there's a similar question here. They're asking basically the same thing in a different concept. So they say, what would the y-intercept represent? So again, that's your initial cost of joining. And then your slope is going to represent your cost over time. This time we do know for sure it is in months. So now let's talk about some special lines. The slopes of parallel lines are always the same or equal to each other. The slopes of perpendicular lines are opposite reciprocal. Now I like to think about the word reciprocal by thinking about refliprical. And refliprical is not a technical math term, but it helps me remember what reciprocal means. So with that, if I tell you that the slope of something is 2/3, then the perpendicular slope, and notice I'm introducing a symbol here. That upside down T symbol right there means perpendicular. So if I have 2/3 as my slope, my opposite means change the sign. Reciprocal, remember, think about that as refliprical. So we're going to flip that fraction upside down. Now, since we've introduced the symbol for perpendicular, let's introduce the symbol for parallel as well. So with parallel, it kind of looks like an 11 as a subscript. So the parallel slope would be exactly the same. Also keep in mind, if you have a slope that is a whole number, we can think of any whole number as over 1. So the perpendicular slope there would be -1/2. So it says write an equation through this point that is parallel to this equation. And I know on your paper you do not have a graph, so I'm going to delete that out so we've got a little bit of space. So if we want to write something that is parallel to this guy, the only thing that matters from that entire equation is the slope. So all I'm going to do is I'm going to steal the slope, and then I'm going to create the parallel slope. So typically on this day, I like to talk about my love of Chick-fil-A chicken minis, right? So we're going to pretend that we're at lunch, somebody's got Chick-fil-A chicken minis, and we're all excited about it. So when we go, we're going to ask this person, hey, can I have one of those? They're going to give us what we need, and because we've now gotten what we need, we're going to walk away. So just like here, we're going to take that slope, we've got what we need, we're going to walk away and never speak to it again, right? Kind of drastic, but we've got the info that we need and we're going to walk away. We also have a point, -1, 1, that we need to use. So now that we have this slope and this point, we're going to use point-slope form of a line. So using point-slope, y minus y1 equals n times x minus x1, I'm going to plug in what I know. Y minus the y-coordinate equals the slope, which I have here, times x minus the x-coordinate in here. So again, when I have that minus a negative, remember that that becomes a positive. Now, if you're reading this carefully, this just says write an equation, which we just did. So if you want to be technical, you could stop right there. Now, in most cases, they're going to ask that you give that in slope-intercept form. So if they did, we would distribute the 2 to both of those terms, add the 1 to both sides, and we're done. However, if you wanted to stop right here, you did technically give an equation, so you could be finished at that point. So again, with this particular question, they ask for perpendicular, but our process is going to be the same. We're going to walk up to this person, we're going to ask for what we need. So we need their slope. Their slope is -2. Once we have what we need from them, we no longer need any other information or items from that equation. But because this is perpendicular, we're now going to change that slope. So instead of -2, it's going to be a positive 1/2. So I've got my new slope, I've got my point. So with the fact that I have a point and a slope, I'm going to use point-slope form. So plugging in what I know, y minus my y-coordinate equals my slope times x minus my x-coordinate. So again, they just asked for an equation, so there it is if we want to stop. However, I know most of you guys like to go ahead and distribute that out, so you can definitely do that if you'd like. And then put that back in good old faithful slope-intercept form. Either one of those will do. So there's a couple of examples here for you to try. If you would like to give those a whirl, you are welcome to. We are, however, going to talk about number 4 together. So how do you know that x equals 4 and y equals 2 are perpendicular? So remember that x equals 4 says that all of the x values are 4 all of the time. So my x values are 4 on this vertical line right here. Every single point, no matter which one I pick, has an x value of 4. For y equals 2, that means that the y value is consistently 2 all the time. Every single point on that line has a y value of 2. So how do I know that they're perpendicular? Well, the way that I know that is because they're forming a 90-degree angle on the graph. One of these lines is vertical and one is horizontal, and I know that those lines always cross perpendicularly. Now, for sake of time in the video, we're going to skip over these guys here. You don't have to worry about that in terms of your homework. But we will talk about a couple of questions here at the end. We'll look at this DVD question and we'll call it quits. So you can rent a DVD at a local store for $4 each. They charge a $15 per month rate for however many rentals as you want. So with that, we're going to have to pay $15 per month, right? So 15 times the number of months. And we're going to rent for $4. So we want to know, how many DVDs do you need to rent to make the online rental better? So one of them offers $15 per month, and one of them offers $4 each. So we've either got $15 per month or $4 per DVD. So what I really want to know is, at what point am I spending more money individually than I would be at the monthly cost? So if I think about that, if I'm renting one DVD, it's $4. If I'm renting 2 DVDs, it's $8. 3 is going to give me $12. So when I rent 4 or more DVDs, that's when I should switch to the other model. Guys, I hope that you have a wonderful rest of the day. If you have any questions, please let me know.